All right, so I've been keeping an eye on the lab Jamboard, and I've noticed that some of you have been taking the slopes of 2 data points on your graph instead of using the slope of the best fit line of your graph. And so I thought I would make a video explaining why the slope of the best fit line is better than the slope of any 2 data points. So I pulled a set of data from the pivot bowling ball rolling left activity we did earlier this year. This was just collecting the position of the bowling ball as a function of time. This data, just by eyeballing it, looks pretty linear. It looks like the position is proportional to the time. But you'll notice that I have here 1, 2, 3, 4, 5, 6, 7 data points, right? So if I picked 2 data points and calculated a slope, I could get different things. And let's see how that works out. So I used Logger Pro, which is the big sibling of graphical analysis, to fit 4 different pairs of data points. And you can see that depending on which 2 pairs I pick, I get different slopes. So I have, for the first 2 data points, minus 54.56 centimeters every second. For the second one, minus 59.99 centimeters every second. For the third one, minus 54.56 centimeters every second. So that happens to be the same as the first one. And then for the last few points, minus 57.1 centimeters every second. So I did 4, and 3 of the 4 were different from each other. But because there are 7 data points, I could have had 21 different choices of pairs, right? I could have picked data point 1 and 2. I could have picked data point 1 and 3. And all of those 21 slopes would be a little different from each other. Did I really want to calculate 21 different slopes? Not really. So I got Excel, or Google Sheets in this case, to do it for me. So I did all possible combinations of data points. You can see in my first 2 columns, I did data point 1 with data point 2, data point 1 with data point 3, etc., so on for all 21 combinations. I talked Google Sheets into doing the math for me. I did not do each of these by myself. If you'd like me to show you how you can get Google Sheets to do your math for you, ask me. That's a different video. But you can see here in column G, I get a whole bunch of different slopes. All right, so 21 different slopes. Which of those 21 is correct? Well, if you have 21 different slopes for the same set of data, maybe the best thing to do is to take the average. The average of all of these 21 slopes is minus 57.52 centimeters every second. But those slopes range from the largest value, remember, for negative numbers, smaller is larger. The largest value of minus 54.6 centimeters every second, all the way up to basically minus 60 centimeters every second. So that's a range of about 5 centimeters every second from the same data set. And depending on which pair you pick, you could get anything in there, right? So now check this out. Here's the same data set that I showed you in the beginning. And this time I used all 7 points to do the best fit line. Look what that slope is. Can anyone see what that slope reads? Minus 57.52 centimeters every second. That is notable because that is the average slope of all 21 different combinations. Right? And the computer does this for me. I just highlight all 7 data points. I click add fit. It sticks a line through it. And instead of having to figure out how to calculate 21 different slopes and average them together, it does it for me. So this is the best possible estimate of the answer. In this case, that's the bowling ball speed, right? Or bowling ball velocity. This is the best possible answer from these 7 data points. And you get it really easily by calculating the slope of the best fit line. If you use any 2 data points, you're not going to get the best possible answer. You're going to get one possible answer, but it's not the best possible answer, right? I hope that makes sense. So punchline, we type it at the bottom of this. using the slope of the best fit line is like taking the average of all possible data point slopes, except way, and trust me, I know it's way faster because I just did it. It took me half an hour. Can I make this all show up in the camera? Come on, box. Okay, so it's like taking the average of all possible data point slopes except way faster. Sorry, that's cut off.